Hi students, welcome to the next class in dilute solutions and colligative properties. In the last class, we have seen the dilute solution and introduction to colligative properties was done. We have also learnt about Raoult's law, which deals with the partial vapor pressure of components in a solution. The law states that the partial vapor pressure at any given temperature for a solution is directly proportional to mole fraction of that component, or I can say that it is equal to the product of mole fraction of the component and vapor pressure of the component in its pure state. That was dealt about Raoult's law. And we have seen that four types of colligative properties were observed. One is lowering of vapor pressure, the other one is lowering of vapor pressure, then elevation in boiling point, depression in freezing point, and osmotic pressure. Now, let us learn with the lowering of vapor pressure. What is lowering of vapor pressure? As we have seen, when a solvent is mixed with a non-volatile solute, some of the solvent particles at the surface will be replaced with these non-volatile solute particles, which makes less vapor per this liquid, hence giving less vapor pressure compared to this pure solvent. Here you observe that these are two pictures which represent pure solvent and solution with a non-volatile solute. Since we need vapor state, I have taken it is with a closed lid state. Okay, so you can observe that here the pure solvent has more vapor in its vapor phase, whereas the solution with non-volatile solute, since non-volatile means unable to become a vapor phase. So these particles which have occupied surface, they cannot escape into the vapor state. Therefore, you will find less number of vapor particles which only belong to the solvent particles. Hence, definitely the vapor pressure of solution with non-volatile solute will be less compared to the vapor pressure of pure solvent. Since we are observing a decrease or lowering of vapor pressure by addition of non-volatile solute, it is taken as lowering of vapor pressure. The term itself describes the lowering of vapor pressure. So what is lowering of vapor pressure? Lowering of vapor pressure is the decrease in vapor pressure of a solution compared to pure solvent when it is added with non-volatile solute. So if we denote P as vapor pressure of solution containing non-volatile solute and P naught as vapor pressure of pure solvent, then it is very clear that P is less than Pa naught. That means vapor pressure of solution containing non-volatile solute is less than vapor pressure of pure solvent, and the decrease in this value is called as lowering of vapor pressure. So it is denoted by P naught minus Ps. Okay, so this is regarding the lowering of vapor pressure. And the next we are going to learn about relative lowering of vapor pressure. What is relative lowering of vapor pressure? By the term itself, it is that it compares how much of vapor pressure is decreased relative. That means we are relating it. So how much of vapor pressure has been decreased compared to the original vapor pressure which we observed for the pure solvent. So it is taken as the ratio of the decrease in vapor pressure compared to the original vapor pressure of solvent. So it indicates the decrease in vapor pressure of pure solvent when added with non-volatile solute to that of pure solvent. That means it indicates the decrease in vapor pressure to that of pure solvent. Okay. So for shortcut, I have taken it as RLVP, relative lowering of vapor pressure. So by definition, it is decrease in vapor pressure by actual vapor pressure. The decrease in vapor pressure is Pa naught, where A indicates solvent, P naught indicates pure state. So this vapor pressure of A, that is solvent in its pure state, minus S indicates solution, vapor pressure of solution. This will be a decrease. And since we want a relative lowering, it should be compared with original vapor pressure. So decrease in vapor pressure divided by original vapor pressure. So this is the important formula which indicates relative lowering of vapor pressure. So relative lowering of vapor pressure is given by P naught minus Ps by P naught. Okay. So I hope you are clear with this. So next, let us go with the Raoult's law for dilute solution. Earlier we have seen Raoult's law for any type of solution. Okay. Now we are giving Raoult's law for dilute solution. Kindly remember the difference between previous Raoult's law and this Raoult's law. It is also same, but it is a special case of Raoult's law. What is that special case? It is applicable for dilute solutions, and the second condition is that it is applicable for non-volatile solute having solutions. Okay, original Raoult's law is applicable for any type of solution, but the Raoult's law based upon conditions such as dilute solution and such as having non-volatile solute have modified original Raoult's law as this one. Hence it is called as Raoult's law for dilute solutions. Now let's see what does this Raoult's law for dilute solution mean. Okay, so Raoult's law for dilute solution means that it indicates for dilute solutions containing non-volatile solute, the relative lowering of vapor pressure is equal to mole fraction of solute. So whatever we have learned, relative lowering of vapor pressure for dilute solutions containing non-volatile solute, it is equals to mole fraction of solute. Okay, so simple. The Raoult's law states that for dilute solutions containing non-volatile solute, the relative lowering of vapor pressure is equal to mole fraction of solute, and it is indicated by P naught minus P by P naught, which is relative lowering of vapor pressure mathematically, and XB, it is mole fraction symbol. B, the subscript, indicates that it is the mole fraction of B, and we have taken the denotion that B indicates solute, A indicates solvent, right? So this relative lowering of vapor pressure is equals to mole fraction of solute. Okay, so now let's see the other one. From next we will look at the derivation of Raoult's law. Okay, so what is how this originally we had this was a Raoult's law. Okay, and how it was converted into this formula, let us see. So from Raoult's law we have the vapor pressure of solution is equals to sum of vapor pressure, partial vapor pressure of solvent and partial vapor pressure of solute. Okay, so PS indicates vapor pressure of solution, PA indicates partial vapor pressure of solvent, and PB indicates partial vapor pressure of solute. Okay, and next how this can be modified into this form. Let us see. Since B we have taken as non-volatile, B is non-volatile, therefore the contribution from B, which is a non-volatile solute, towards vapor pressure will be 0, right? Since it has no vapor by its nature. Therefore, the total pressure of the solution, total vapor pressure of the solution will be only due to A, which is solvent. So therefore, the PS, vapor pressure of solution, will be equals to PA, partial vapor pressure of solvent. Okay, so we know that from Raoult's law, the partial vapor pressure is given as the product of mole fraction of that component with the product of the vapor pressure of that component in its pure state. That means PA is equals to XA into PA naught, where XA is mole fraction of solvent and PA is vapor pressure of the solvent in pure state, since we have taken A as solvent. Okay, so just substitute XA, which is mole fraction of solvent, in terms of mole fraction of solute. How can we do that? Since we need the form in XB, just convert XB in XA into terms of XB. For binary solutions we know that, or for any composition we know that the sum of mole fractions is equals to unit. Okay, so XA plus XB equals to 1, since we have only two components A and B. So XA plus XB will be equals to 1. If I want XA, then XA will be equals to 1 minus XB. Substitute this value here. So then it becomes PS equals to PA equals to XA PA naught, which is equals to 1 minus XB into PA naught. 1 minus xp into Pa naught. So, so we will have that. So just divide Ps with Pa naught. So Ps by Pa naught will be equals to 1 minus xp, or just take xb on one side. Therefore, it will be xb equals to 1 minus Ps by Pa naught. Just take the LCM, then it will be Pa naught minus Pa by Ps by Pa naught. In simple representation, just removing the subscripts, I can take it as P naught minus B by P naught, which is relative lowering of vapor pressure. So we finally got the expression that the mole fraction of non-volatile solute is equals to relative lowering of vapor pressure of the solution. So this thing has been derived for your verification. So I repeat, the Raoult's law for general solutions is different, and it has been modified as the Raoult's law for dilute solutions when you take a dilute solution condition with non-volatile solute dissolved in it. Okay, I hope you are clear with this. In the next class, we will learn about the molecular weight determination using relative lowering of vapor pressure, which helps the importance of colligative property. Okay, so if you have any doubts, please let me know. Thank you. Thanks for listening.